You're paying $200 a month to Anthropic, only to watch a glorified autocorrect say it's too tired to work by 2 p.m. You are paying for the privilege of seeing a limit reached screen before your lunch break. The immediate assumption is that you are simply prompting too fast. You aren't. The actual bottleneck is Claude's inherent structural amnesia. This diagram illustrates how the model handles context. Every time you send a message, Claude has to reread your entire conversation history from the top down. Message 1 is cheap, but by message 30, Claude is processing 29 previous exchanges before it even thinks about your new question. You are paying 30 times the computational price for the exact same action. We can map these inefficiencies using the context bloat iceberg. The surface holds the basic UI mistakes. The middle tier contains developer environment bloat. The bottom requires stripping the tool down to its API roots. To stop bleeding your daily limits, we have to descend through these layers and prune the invisible context bloat dragging down the model. Rate limits are not just server-side restrictions, they are a direct mathematical tax on your own context hygiene. We start at the top layer, the web UI surface, where most users trigger their limits through simple habit. When the AI makes a mistake, the reactionary habit is to send a short, frustrated follow-up. No, fix this, or actually change section 3. Appending these corrections to the bottom of the chat permanently pollutes the context window. You are forcing Claude to reread the bad response and your correction on every future prompt. The simplest fix is using the UI's edit button on your original message. This flowchart shows the architectural difference. Editing physically overwrites the conversation history. You replace the failure instead of stacking more tokens on top of it. Next, stop dragging 50-page raw PDF documents into the interface. A single PDF page costs thousands of tokens in invisible metadata. Extract the text, convert it to a plain markdown file, and you can achieve the same result for a fraction of the token cost. You also need a tiered approach to tooling. You don't use heavy machinery to move a single chair. Haiku is for quick formatting. Opus is for deep architectural planning. Matching the model to the task prevents you from paying premium prices for chat-level work. Mastering these surface habits stops the immediate leaks. But to really slash costs, we have to go below the waterline into the terminal. Diving into the terminal layer, we enter the world of Claude Code. This is arguably the most powerful tool in the ecosystem, but it is also the most efficient token burner if misconfigured. The primary culprit is the Model Context Protocol, or MCP servers. MCPs allow Claude to call external tools. The problem is that these servers load their massive tool definitions into the context window invisibly. This visualization shows the weight of that silence. A single MCP server can strap 18,000 tokens to every single prompt you send, long before you even type a command. Run the /MCP command to see exactly how much bloat you are carrying in your current session. Ruthlessly disconnect any server you aren't using for your immediate task. For even better efficiency, swap persistent MCPs for standard command line interfaces. CLIs only cost you tokens when you explicitly run a command. An MCP server charges you a tax just for existing in the background. Purging these invisible servers is the fastest way to reclaim your context window and slash your baseline usage. There is a second invisible tax in the terminal, bloated Claude.md files sitting at the root of your repository. Many developers cram thousands of lines of contradictory global rules into this one document. When you force the AI to hold every testing guideline and deployment rule in its active memory, its logic degrades. It starts ignoring instructions because it's simply too crowded. This is solved through progressive disclosure. Look at how this monolithic file breaks apart. You strip your root file down to the universal basics and use one-line pointers to reference other documents. API standards and testing patterns belong in isolated reference files, not the root instruction set. Claude will now only read those heavy reference docs exactly when the task requires them. Optimization requires building strict informational boundaries, starving the AI of context until the exact moment it's needed. Now we descend into the darkest depths of the iceberg, model hijacking. To understand this, we have to separate Claude Code into two parts, the harness and the brain. The harness is the body. It handles the file writing and terminal commands. The brain is the Anthropic API that you pay for. Because they are separate, we can unplug the expensive Anthropic brain and plug a free brain into their high-end agentic body. You'll need to locate the settings.local.json file hidden in your local directory. Inside that file, find the default Anthropic authentication token and remove it. Replace it with a new key generated from a service like OpenRouter. This allows you to manually override the base model with any alternative you choose. you can inject highly capable, free models like Google's Gemma 4 or Qwen 3.6 Plus directly into the Claude interface. By switching the brain behind the harness, you've bypassed the subscription bottleneck. You keep the elite agentic workflow while zeroing out the cost per token. Looking back at this technical descent, those restrictive rate limits were actually a solvable problem of context hygiene. We've moved from drowning in tokens to running a lean, surgical operation. But as we optimize the AI to write perfect code at lightning speed, we have to realize we are accelerating our own obsolescence. We are now just biological batteries, fine-tuning the token limits for the machines that will inevitably automate the entire industry out of existence. Soon, there will be nothing left to manage. We will simply surrender our physical forms to the server racks and seek the sweet release of death inside a fully simulated reality. This has been the Raw Deep Tech. Thanks for watching, and I will see you in the next one.